the universe is vast and full of mysteries. Most of the time, those mysteries stay far away, twinkling in our night sky as distant, beautiful lights. But what if one of those mysteries decided to pay us a visit? What if it wasn't just a rock, but something more? Imagine a top scientist, someone who has spent their entire life looking at the stars, suddenly sounding an alarm. This isn't science fiction. It's happening right now. A very serious warning has been issued from the halls of Harvard University. It's a warning about an object hurtling through our solar system on a path that will bring it uncomfortably close to home. It's a story about a potential discovery that could change everything we know about our place in the cosmos. This isn't your typical story about an asteroid or a comet. Professor Avi Loeb, a respected astrophysicist, believes this visitor might be something else entirely. Who is the scientist sounding this incredible alarm? He is Avi Loeb, a professor of astrophysics at Harvard University. He isn't just any scientist, he's a prominent and often controversial figure who isn't afraid to challenge the status quo. For years, he chaired Harvard's astronomy department, guiding its research into the deepest questions of the cosmos. He has published hundreds of scientific papers on topics ranging from black holes to the first stars that ever lit up the universe. Professor Loeb is known for his brilliant mind and his willingness to explore ideas that other scientists might consider too speculative or too out there. Professor Loeb founded the Galileo Project, a research initiative dedicated to the systematic scientific search for evidence of extraterrestrial technological artifacts. This isn't about chasing blurry photos or unsubstantiated UFO sightings. The Galileo Project aims to use rigorous, transparent, and data-driven methods to investigate unidentified aerial phenomena, or UAPs, and other interstellar objects. Every night, powerful telescopes around the world scan the skies, cataloging anything that moves. They are our planetary defense system, designed to spot asteroids and comets that might pose a threat to Earth. It was one of these survey programs, the Asteroid Terrestrial Impact Last Alert System, or ATLAS, that first flagged a new object in early 2024. At first, it seemed like just another faint speck of light moving against the backdrop of distant stars. It was given the designation 3I/Atlas, with the I standing for interstellar, marking it as only the third such object ever detected. This meant it didn't originate from within our solar system. It was a traveler from another star system, a true cosmic immigrant. What immediately made 3I/Atlas so strange was its path. Our solar system is a relatively flat disk, like a vinyl record, with all the planets orbiting the sun on roughly the same plane. Based on its brightness, astronomers calculated its size and were stunned. Initial estimates suggested 3I/Atlas could be enormous, perhaps several kilometers in diameter. An interstellar object of this magnitude had never been seen before. The first interstellar visitor, Oumuamua, was tiny in comparison. How could such a massive object be ejected from its home star system and travel for millions of years, only to end up on a precise trajectory that would bring it into our neighborhood? The odds of such an event happening naturally seemed incredibly small. As scientists pointed more powerful instruments at 3I/Atlas, they expected to see the classic signs of a comet. Comets are essentially giant, dirty snowballs. As they get closer to the sun, the heat causes their ice to vaporize, creating a glowing atmosphere called a coma, and a long, beautiful tail of gas and dust. But 3I/Atlas wasn't cooperating. Despite its close approach to the sun, it showed no significant coma or tail. This lack of cometary activity was a major red flag for Professor Loeb and his team. If it's a giant ice ball, why isn't it melting? This is the core of Loeb's argument. He proposes that 3I/Atlas may not be a natural object at all. What if it's an artificial construct, a piece of alien technology? This would explain its odd characteristics perfectly. An alien probe, built from advanced materials like reinforced metals or carbon composites, would not sublimate or break apart as it approached the sun. The object's rare journey adds another layer to the suspicion. Think of the universe as a vast ocean. Natural objects drifting between star systems are like messages in a bottle, tossed randomly by the cosmic currents. But 3I/Atlas isn't just drifting. It's on a precise path that will bring it close to the third planet from our sun, a planet teeming with life. Professor Loeb argues that this might not be a coincidence. An intelligent civilization wanting to explore other star systems would likely send probes on targeted missions, aiming for planets in the habitable zone where life might exist. If 3I/Atlas is indeed an alien probe, we must ask a critical question. Is it friendly? The hope for benevolent, wise aliens has been a staple of our dreams for decades. We imagine them sharing advanced knowledge, helping us solve our biggest problems, and welcoming us into a galactic community. But there is a much darker, more unsettling possibility that some scientists and thinkers take very seriously. It's known as the dark forest hypothesis, a concept popularized by the science fiction author Cixin Liu. This theory offers a chilling solution to the Fermi paradox. The question of why, in such a vast universe, we haven't found any evidence of other intelligent life. The dark forest hypothesis paints the universe not as a welcoming neighborhood, but as a terrifyingly quiet hunting ground. It suggests that all intelligent life lives in constant fear of being discovered by others. Why? Because you can never know the intentions of another civilization. They could be peaceful, but they could also be hostile and expansionist. Given the immense distances between stars, communication is nearly impossible, and misunderstandings could be catastrophic. The safest course of action for any intelligent species is to remain silent and hidden. If you reveal your location, you risk attracting a predator who might decide to eliminate you as a potential future threat. The story of 3I/Atlas doesn't exist in a vacuum. It actually has a fascinating and, controversial predecessor that paved the way for this kind of thinking. Back in 2017, astronomers detected the very first interstellar object ever observed in our solar system. It was named Oumuamua, which is a Hawaiian word meaning a messenger from afar arriving first. From the moment it was spotted, Oumuamua was just bizarre. It was small, roughly the size of a football field, and had this highly unusual, elongated shape, maybe like a cigar or even a flat pancake. It was tumbling through space in a pretty chaotic way, and just like 3I/Atlas, it showed no cometary tail, even as it passed close to the sun. What really baffled scientists was Oumuamua's movement. As it flew away from the sun, it actually accelerated. It pushed away from the sun with a force that just couldn't be explained by gravity alone. Now, for comets, this kind of thing is normal. The outgassing of vaporized ice acts a bit like a tiny rocket engine, giving them a slight push. But Oumuamua had no visible outgassing. It was at this point that Professor Avi Loeb first proposed his alien technology hypothesis. He suggested that Oumuamua's strange acceleration could be explained if it were not a rock, but a light sail. A light sail is a form of spacecraft propulsion that uses the pressure from sunlight itself to move along. It would have to be an incredibly thin, lightweight, and large surface. This would perfectly explain why it accelerated away from the sun without any outgassing. It was being pushed by the photons streaming from our star. The warning about 3I/Atlas has galvanized the astronomical community into action. This isn't just a theoretical debate anymore. It's really a race against time to gather as much data as possible before the object flies past us and disappears back into the interstellar void. Major observatories around the world, from the mountains of Chile to the islands of Hawaii, are dedicating telescope time to track 3I/Atlas. They're using powerful instruments to study its brightness, its color, and its trajectory with, honestly, unprecedented precision. Every pixel of data is a potential clue that could help us solve the mystery of its origin and nature. Scientists are employing a technique called spectroscopy. This involves breaking down the faint light reflecting off the object into its constituent colors, kind of like a rainbow. Each element and compound absorbs and reflects light in a unique way, creating a chemical fingerprint. By analyzing this spectrum, astronomers can figure out what the object is made of. If they find the signature of water ice or other volatile compounds, it would strongly support the theory that it's a comet, though a pretty strange one. Beyond optical telescopes, scientists are also using radio telescopes to listen for any potential signals coming from the object. The search for extraterrestrial intelligence, or SETI Institute, and other organizations are pointing their massive radio dishes at 3I/Atlas's position in the sky. They're scanning across a wide range of frequencies, listening for any non-natural structured signal. So far, there's just been silence. But the listening campaign is going to intensify as the object gets closer, since any potential signal would become stronger and easier to detect. All eyes are on the calendar. The climax of this cosmic drama is set for late December 2025. That's when 3I/Atlas will make its closest approach to Earth, passing within a few million kilometers of our planet. In astronomical terms, that's actually a very close shave. It's an incredible opportunity for observation, since the object will be at its brightest and most visible to our telescopes. It's during this crucial period that we'll have the best chance to unravel its secrets. The data collected in December could either confirm it as a natural object, putting an end to the speculation, or provide the smoking gun evidence that it's something far more extraordinary. The uncertainty of what will happen is, well, palpable. A friendly or neutral probe might simply scan our planet, gather data, and continue on its journey, leaving us with the paradigm-shifting knowledge that we are not alone. If the probe is hostile, its close approach could be a prelude to something far more sinister. It could be a reconnaissance mission to assess our defensive capabilities before a larger force arrives. It could deploy smaller probes into Earth's orbit for long-term surveillance. In the most extreme and honestly terrifying scenario, the probe itself could be a weapon, designed to cause damage on a planetary scale. Regardless of what 3I/Atlas turns out to be, its journey through our solar system serves as a powerful reminder of our place in the universe. We're inhabitants of a small, fragile world in an unimaginably vast and ancient cosmos. Objects like Oumuamua and 3I/Atlas force us to lift our gaze and rekindle our sense of wonder. They're invitations to be curious, to ask the biggest questions we can imagine. Is there life elsewhere? What forms might it take? What can we learn from it? At the same time, this event teaches us the importance of caution and preparedness. Whether the threat comes from a natural impactor or, as the dark forest hypothesis suggests, from a potentially hostile intelligence, we need to be vigilant. Investing in planetary defense, improving our ability to detect and track objects in our cosmic neighborhood, is not a luxury. It's a necessity for the long-term survival of our species. We must be prepared for the unknown. This means funding scientific research, building better telescopes, and developing the technology to respond to new discoveries, whatever they may be. This moment also calls for scientific courage. Professor Avi Loeb has faced considerable criticism for his bold ideas, yet he continues to push the boundaries of inquiry. Science thrives on this kind of courage, the willingness to propose and test unconventional hypotheses, even in the face of skepticism. We must support and encourage this kind of thinking, fostering an environment where new ideas can be debated openly and rigorously, based on evidence, not on preconceived notions of what is or isn't possible. Ultimately, the story of 3I/Atlas is our story. It's a reflection of our hopes, our fears, and our enduring quest for knowledge. As we watch and wait for this mysterious visitor, we are united as a species in a shared moment of anticipation. It's a chance to remember that we are all crew members on Spaceship Earth, traveling together through the great dark forest of the universe. Whether we are alone or not, our future depends on our ability to work together, to stay curious, to be cautious, and to find the courage to face whatever wonders or challenges the cosmos has in store for us. The sky is not the limit, it's an invitation.